Hello, PreCalc. I hope the test today went well. Probability is not the easiest subject, but it does have a lot of practical use, so I hope you found it rewarding. We are probably going to finish up our last section this year with functions. And we're watching it after the test day, 5/2, May 2nd. And we're going to do functions. All right, functions, I'm going to assume that you've come to me knowing what a function is. And a function is that for every element of the domain, there is one and one only element in the range. So it's a relationship between variables. So let's look at an example of a function. And this is a special function. It's called a piecewise. A piecewise function. So an example would be f of x, which you can think of as y. So I could use y equals or f of x equals. They mean the same thing. Or g of x, h of x, x squared plus 1. Comma, x is less than 0, and x minus 1 when x is greater than or equal to 0. So a piecewise function comes in pieces, thus its name. So we have one piece when x is less than 0 and a different piece when x is greater than or equal to 0. So if we are going to evaluate a function, we can do that with this symbol tells us to. F of -1 means find the value of this function at -1. It's read f of -1. And I want you to find f of -1 for this piecewise function, f of 0 and f of 1. So let's recall how to use these. To find out f of -1, we have to know which piece to look into. So is -1 in this domain or in this one? So the answer is it's in the x is less than 0. So we're going to put in -1 into this piece and evaluate it. So f of -1 equals x, and whenever there's an x, I'm going to put in the -1. So notice it's squared plus 1, because -1 is in this piece. So I'm going to use this part of the function to evaluate it. -1 squared is 1, plus 1 is 2. F of 0, which piece should we pick this time? Well, the piece that has 0 in it, this says x is less than 0. So x is greater than or equal to. So since it's or equal to, that's the piece that we will use to evaluate f of 0. So I'm going to put a 0 in for x in that piece, and I get a -1. F of -1, see if you can do that one. Oops, I'm sorry, it's f of 1. We already did f of -1. F of 1, see if you can do that one. You find that 1 is in the piece where x is greater than or equal to 0, so I'm going to use that piece. And I get a 0. Alright, hopefully you got that. The other thing we're going to look at tonight, so you'll be evaluating functions. This is called evaluating functions when you're asked to put numbers into functions with this notation. Another thing we're going to look at tonight is called the difference quotient. Alright, the difference quotient has basically a form to follow, and f of x plus h minus f of x divided by h. And that won't seem extremely meaningful to you, but this is a pre-calculus class, so when you get to calculus, this will look very, very familiar. An everyday sort of occurrence. So I just want to expose you to it this year, so it won't be so shocking next year. So there's a little song. It's like I will give you a problem. I won't give you this. I'll say find the difference quotient. So you have to know this. So I'll give you a little song. F of x plus h minus f of x divided by h divided by h. This is the difference quotient. Alright. Alright, h cannot equal 0 because we would be dividing by 0, and that is not allowed in the number system. So let's go ahead and find the difference quotient. For this function, f of x equals x squared minus 4x plus 7. Alright, so we're going to find out how to evaluate this function and find the difference quotient for it. We're going to go first to this part. It says to take this function and put in x plus h. So let me do a little training here, and then I'll erase it and go back and actually start this problem. So somewhere on the side you can write this. Suppose we have a function. We'll call it this function right here. So this function is f, so that's the f machine. So we're going to put some values in the machine and see what comes out. So if I put in x into this machine, this is telling me that what comes out is x squared minus 4x plus 7. What if I put a 0 into this function? Well, it'll take whatever I put in it and square it, subtracts 4 times whatever I put in it, and adds 7. So if I put in a 0, it's going to be 0 squared, which is 0, minus 4 times 0, 0, plus 7. So it spits out a 7. What if I put an a into my function? It comes out whatever I put in, it will square it, minus 4 times whatever I put in, plus 7. So I'm going to get a squared minus 4a plus 7. What if I put in star? Whatever I put in, it will square it, subtract 4 times whatever I put in, and add 7. So a function is like a machine, and it will do the same thing every time. So what if I put in brie? I'll get brie squared minus 4 times brie plus 7. Alright, so I'm running out of room here. Let me borrow from my 0 space. What if I put in an a plus b? Again, this function will square whatever I put in, subtract 4 times whatever I put in, add 7. So it's going to square the a plus b, subtract 4 times the a plus b, and add 7. Alright, so to make a long story short, we are putting in an we're putting in an x plus h. So f of x plus h means what comes out when I put x plus h into the function. So if I put x plus h into this function, coming out is x plus h quantity squared minus 4 times x plus h plus 7. Alright, do you get that? I'm going to ask you tomorrow about these things. So study that and rewind that if you didn't quite follow it, and make sure you watch the video and not the video watching you. Alright, now that you are all trained, we are going to do the difference quotient for this example. So we're going to do f of x plus h minus f of x divided by h. So we just obey this command. So we're going to put x plus h into this function. What will it spit out? X plus h quantity squared minus 4 times x plus h plus 7. So I have just completed this part. Check. Now I hit a minus sign. Check. It will affect everything behind it, so I'm going to give myself a parentheses. And this says f of x. Well, f of x is defined, x squared minus 4x plus 7 divided by, check, divided by h, check. So we did everything that the difference quotient commands us to do. So now I've got to simplify that. Don't have much room down here, do I, to do that? So I'm going to pop up here. So you can keep going below. Alright. So I have to square x plus h. To square any two binomial, two quantities added, it's always the square of that plus this times this doubled plus the square of that. So that's the quick way. And if you don't believe it, you can take x plus h and multiply by x plus h, and you can do the 4 steps, and you will find out that it does equal this. Quick way again, square this, multiply these together and double, square that. Alright, minus, and this is 4x plus h, but it's affecting, that minus sign will affect everything behind it. So it makes both terms, the 4x and the 4h are both negative, plus 7. So I've taken care of this, this, and this. There's my minus sign. That's a 7, by the way. And now everything behind the minus sign is affected by it. So I get minus x squared plus 4x and minus 7 all over, just draw a straight line, h. Alright, now difference quotient becomes a lot of fun at this point because everything, a lot of things cancel out. So if you don't find many things canceling out, you probably have some sign errors or some setup errors. So here we have a minus 4x and a plus 4x, and a plus 7 and a minus 7, and a plus x squared and a minus x squared. Now I have left a 2xh, an h squared, and a minus 4h. And all that is still divided by h. So each of the terms in the numerator have an h, and that will be each of the, if they each have 1, I can cancel the bottom one. And this has x squared, h squared, so it'll become h. So the final answer is left is a 2x, a plus h, and a minus 4. Alright, that is the difference quotient for this. Alright, again, it's not extremely meaningful, but I do need you to be able to do it for your calculus, if calculus calls your name. Alright, if not, you have been trained, and training your brain is never a bad thing. Alright, that's all our fun for tonight. So the functions will entertain us for quite a while, and probably take us up into the time we're ready to review for our final. Lots of things we can do with functions, And I think you've seen them all before, so we're kind of ending on a review note. Alright, so I will see you tomorrow. Carry on.